welcome back to D-Machine, the channel where we slow down modern industry and show the real work behind the things that keep our world moving. Today we're stepping into a Chinese factory to follow the full process of making automotive leaf springs. The tough, old-school suspension parts that have been carrying trucks, trailers, and heavy loads for over a century. A leaf spring looks simple, just curved steel, but it's built to flex millions of times without cracking. That kind of strength doesn't happen by accident. In this video, you'll see raw spring steel transformed through cutting, drilling, heating, forming, heat treating, surface strengthening, and coating, step by step. Let's head inside. Every tough leaf spring starts life in the quietest place in the whole factory, the raw steel yard. These long, heavy bundles are spring-grade flat bar, tagged, stacked, and kept in order so every batch stays traceable. A worker guides the lifting straps as the bundle is moved into position, because one wrong swing can scar an edge or bend a bar before the work even begins. From here, the steel feeds into the first line where rollers and clamps control it, straight, steady, and perfectly aligned. Then comes the first real making step, cutting the bar down into individual blanks. Each blank is the future leaf of a suspension pack, and the length has to be consistent, because later, every leaf must share load evenly. Once the steel blanks are cut to length, the factory moves into precision work, the kind of detail that decides whether a leaf spring feels smooth for 10 years or starts clunking after one season. On this line, every strip is carried forward by chain conveyors and guided by hard stops. That indexing is everything. If a hole lands even a few millimeters off-center, the entire spring pack can shift under load, the center bolt won't sit true, and alignment problems will show up later as uneven wear. At the first station, the blank is clamped down so it can't walk or twist. Depending on the design, the plant may punch pilot holes quickly, fast, repeatable, and consistent, then send the part to drilling for final size. Drilling might look slow compared to a punch press, but it gives clean geometry. With coolant flowing, the bit stays cool. Chips evacuate, and the edge of the hole won't tear or smear. That clean edge matters, because these holes will see vibration for hundreds of thousands of miles. By the end of this step, the blanks are no longer just strips of steel. They're located parts, ready to be formed, heated, and turned into something that can hold a truck's weight without flinching. This is where the factory stops treating steel like a raw material and starts treating it like a living thing. Because once heat enters the process, everything becomes about timing, temperature, and control. The blanks feed into a long reheat furnace. You can see that orange glow pouring out under the hood, and it's not just dramatic, it's the window into the most sensitive part of the job. In spring steel, temperature isn't a suggestion. Too cold, and the material fights the rollers and cracks at the edges. Too hot, and you risk surface damage, excessive scale, and a microstructure that won't respond the way it should later during heat treatment. When the strip exits the furnace, it's carrying a layer of scale on the surface. Dark, brittle oxide formed by heat and oxygen. The line doesn't give it time to cool. Heavy feed rollers grab the piece and pull it forward, keeping it straight, keeping it centered, and keeping it moving at the right speed. Now the real shaping begins. Those roller stands and forming stations do more than flatten. They control the profile, thickness transitions, face consistency, and geometry from end to end. In many spring designs, the goal is to manage stress. A smooth transition is how you avoid a stress riser, the kind of weak point that turns into a crack after years of flexing. Then you see the hot strip meet a die station. Steel against steel. A fast squeeze can form specific features: seat areas, transitions, or locating flats. Details that don't look exciting on camera but matter on the road. Because when a vehicle hits a pothole, every leaf in the pack wants to slide, twist, and shift. Good geometry keeps it disciplined. At the end of this step, you're looking at a part that has been shaped while it's soft enough to obey. So later, when it's hardened, it will keep that shape for the rest of its life. Here's the signature move, the one you can spot from across a garage, the spring eye. The end of each leaf has to curl into a tight, accurate loop, and that can't be done cold. So the line heats the end until it glows. That bright orange isn't just heat, it's ductility. At that temperature, the steel can bend without tearing. And once it's out of the heat, you don't have long before it starts to stiffen again. That's why this station feels like choreography. Workers guide the hot leaf quickly into the forming rollers. The rollers start the curl, pulling the end around, keeping the bend smooth, and preventing a sharp kink that would become a future crack. Then it moves into a die or press that tightens the shape to the final diameter. This is more than just making a loop. The spring eye is where the leaf spring mounts to the vehicle through a pin and a bushing. If the eye isn't round, the bushing will wear unevenly. If the surfaces are rough, it will squeak. If the geometry is off, the suspension won't articulate cleanly, and the whole truck will feel harsher. You can also see why quality matters here. That curled end will flex, rotate, and carry load for years. One small defect in the bend can become a fatigue crack. Slow at first, then sudden when the vehicle is loaded. When the finished pieces stack up, you can see it clearly. These aren't steel strips anymore. They're recognizable suspension parts, formed, consistent, and ready for the next stage that locks in strength: heat treatment, peening, and coating. This is the moment the leaf spring earns its reputation. Up to now, we've cut, punched, and formed the steel. But none of that matters if the metal's internal structure isn't right. So the factory moves into heat treatment, quenching and tempering, the two steps that decide whether a spring will survive years of flexing or fail early from fatigue. First, the formed leaves are loaded onto the heat treat line and fed into a furnace. Inside, the steel is brought up to a tightly controlled, austenitizing temperature. You can see the orange glow as each piece reaches that ready heat. Hot enough for the structure to transform, but not so hot that the surface burns or the part warps. Then comes the fast part, quenching. The moment the leaf exits the furnace, it's transferred into a quench section, where you see that violent steam and spray. This rapid cooling locks the structure into a hard phase, giving the spring its raw strength. But strength alone isn't enough. A spring that's too hard becomes brittle. That's why the next stage is tempering. The parts go back through a controlled reheat, easing internal stresses and tuning the hardness to the sweet spot. Strong, tough, and able to flex millions of cycles without cracking. Afterward, the leaves cool on conveyors and racks, their surfaces showing heat scale and that mottled finish that tells you they've been through serious thermal work. From here, they're ready for the next durability steps, like shot peening and protective coating, before final assembly. After heat treatment, these leaves are strong, but they're not finished. In fact, this is the stage that separates a spring that lasts from one that cracks early. First, the leaves are handled in bundles and fed back into the line. You'll see workers guiding curved pieces into a machine that looks almost like a moving comb of steel fingers. This is the rough and tough world of surface finishing, where the goal is to remove heat scale, control the surface, and prepare the steel for long-term fatigue resistance. Then comes one of the most important durability steps, shot peening. The leaf passes through a blasting zone where high-speed media strikes the surface over and over. It's not sandblasting for looks. Each impact creates a thin layer of compressive stress on the surface, exactly where fatigue cracks like to start. Done right, this step can dramatically improve the spring's resistance to repeated flexing. After peening, the factory can't just assume every piece stayed perfect. Springs can move slightly during heat and cooling, so the leaves go to straightening and checking. You'll notice fixtures with heavy arms and pins, simple, brutal tools that confirm alignment, camber, and fit at the mounting points. If a leaf sits off, it gets corrected now, before it ever becomes part of a pack. Finally, everything is sorted and stacked in clean, consistent bundles. By this point, the steel has the strength, the surface protection, and the geometry it needs. Next, the factory will move into coating and final assembly, where individual leaves become a complete suspension unit. Once the steel has been heat treated and surface strengthened, the factory has to solve the next enemy: corrosion. Because a leaf spring doesn't live in a clean showroom, it lives under a truck, eating road salt, rainwater, mud, and vibration for years. This is the coating stage, and it starts the same way every serious paint line does: handling and spacing. Workers hang the leaves in organized stacks, making sure each piece has clearance so the coating can reach the surfaces evenly. If parts touch, you get bare spots, perfect places for rust to start. Inside the spray booth, the atmosphere changes. It's darker, wet, and loud, and you can feel the overspray in the air. The operator works methodically, sweeping the gun across each leaf to build a uniform film, especially around edges and ends, where corrosion always begins first. The goal isn't a pretty finish, it's coverage and adhesion. When the leaves come out, that deep black coat tells you they're ready for real service. You can see clean, consistent surfaces, and you'll also notice markings, batch codes, or identifiers, so the factory can trace each set back to its production run. From here, these coated leaves will be paired, stacked, and assembled into spring packs, center bolt, clamps, bushings, and final checks, until they're ready to carry weight on the road. And that's the beauty of it. Something that looks as simple as curved steel is actually the result of careful heat, precise forming, and hard-earned factory discipline. These leaf springs won't just carry weight once. They'll flex and recover millions of times, mile after mile, year after year, just like the ones many of us grew up seeing under old pickups and work trucks. If you enjoyed this kind of behind-the-scenes manufacturing, hit like and subscribe to D-Machine for more factories, machines, and old-school industrial processes that built the modern world. And tell me in the comments, what part of this process surprised you most?